So good morning to all of you MSc Physics second year student. So today again welcome to lecture series on energy study first subject, and we want to continue our third chapter, which is the basics of the heat transfer. And we want to continue our point, which is the types of the heat transfer. And in this point already we have to see that the first type of the heat transfer, which is by conduction. Second type, which is continue for the heat transfer by the radiation. And in this radiation already we have to see the understanding the concept of what is mean by absorptivity and what is mean by the reflectivity. In today's lecture we want to see our next point, which is the what is mean by the transmittivity, or we have to know that the relation for which is given as, that is the alpha, that is absorptivity, plus rho plus tau, that is equal to unique, that is the 1. So this is the main relation for incident radiation. This is the important relation for incident radiation, which is incident from the surface, incident of the surface, and whatever phenomena there, the absorptivity is there, reflection is there, and transmission is there. Okay, and that addition or sum of this absorption, reflection and transmittivity, that relation is going to as the 1. So generally consider as this transmittivity is like a function of similarly absorption and reflection, but it is also the function of transmittivity is a function of wavelength and the angle of the incident radiation or incoming radiation. So that we have to consider, that is, if you know that that absorptivity and reflectivity is equal to 0 if alpha plus rho is equal to unique, that is 1, and therefore that is the tau is equal to 0, and that surface which is considered as the reflected surface or which is considered as the opaque surface, and here in this condition, so that is the transmittivity is 0. Transmittivity is 0. Okay, and if we consider that alpha plus rho is equal to 0, and that therefore that condition will obtain here, that tau is equal to 1. Tau is equal to 1. So that surface which is considered as perfectly transparent surface, perfectly transparent surface, perfectly transparent surface. Okay, and if we consider, so that transmittivity is a function of transmittivity is a function of wavelength, function of wavelength and angle of incident or incoming radiation, and angle of incoming radiation, angle of incoming radiation. Okay, so that is known as the transmittivity. And we have to know that tau is equal to 0, so that is considered as the opaque surface, and tau is equal to 1, so that is considered as the transparent surface, or which is considered as the also translucent, because that is the dependent on the both upon the reflection and absorption of the radiation. So that the important formula which is incoming here, if we calculate the transmittivity, that is tau rho, is the first calculated considering the absorption alone, and that formula which is given by tau rho of with respect to that the reflectivity or the refractive index, that 1 minus rho upon 1 plus twice n minus rho. So this is not important point. Actually we want to see here, so that how it is the calculated by the transmittivity with respect to if absorption is there or if reflection is also there for the incoming radiation. So that transmittivity, which is the function of the refraction of the radiation, or which is considered as the transmittivity, are the refractive index n and the extinction of the coefficient k of the medium, which is strictly speaking, and that both n and k are also the function of the wavelength lambda. So that is considered as the transmittivity is the function of the refractive index n. So that is also one of the main point. Transmittivity is a function of wavelength of the angle of the incoming radiation, and second one which is considered as this transmittivity is a function of refractive index of n. Okay, and if we see that the general idea of the figure, what is mean by the reflection, what is mean by the transmission, or what is mean by the absorption. So that if we consider, so this is the material surface, okay, that we have to consider two faces or one faces or semi transparent faces. So whatever material, so that incident radiation, which is considered as the intensity, which is I naught, and this radiation which is considered as the incident radiation, okay, and this radiation which is incident on this surface, we have to draw a perpendicular, and that perpendicular which is called as the normal, okay, so that is denoted by n. And the angle which is created between this normal to this incident ray, so that is considered as the theta I. So that is considered as the angle of incident. After that the reflection is take place, so that intensity of this reflected ray, which is considered as the I rho, and this is the angle which is between that normal to this reflected ray, so that is considered as the theta r. We have to consider as the theta r, that is the angle of reflection. And after that this phenomena sum of the ray, which is absorption, is there, and the partially this wave having the property of the material, depends on the material. So that ray or that wave which is transparent or refracted from this one medium to another medium, and that angle which is considered as the TR, or which is considered as the theta r. So that is mean by the angle of the refraction. So this is considered as the reflected radiation, okay, and this is known as the transmitted radiation, okay. And we have to know that the, for example, the refractive index which is considered for this medium 1, okay, so that first which is considered as the medium 1, and this is the which is considered as the medium 2, okay, and this is considered as the refractive index n1, and this is considered as the refractive index of n2. So this is the general idea, which is what is mean by the absorptivity, what is mean by reflectivity, and what is mean by the transmittivity, okay. So now next point we want to start, So if we consider that solar energy work or use the black body, which is the concept to appropriate or which is considered as the approximate radiation pattern from the actual bodies, and that have the two important example. So that the main point which is considered as the solar energy work in solar energy work in solar energy work we use the black body concept. We use the black body concept, black body concepts to approximate radiation to approximate radiation so that radiation we have to use as a patterns from actual bodies. So radiation which is patterns or which is passes, so that passes from actual body and here we have to give that two important types or two examples which is given here. So that consider as the two examples which is given here. So that first example or type of the radiation which is considered as the sun radiation, So that first example which is considered as the sun radiation. So what is mean by the sun radiation, or what is idea which is given, or what is the ideal temperature or the range of the temperature which is given? So that first of all we have to know that the sun which is assumed to a black body. Okay, so that the sun assumed to a black body, okay, and if we to assumption that sun as a black body, so what is the temperature range? That with the surface temperature of with a surface temperature of 5762 degree Kelvin. So that huge amount of temperature having this sun body, and this is known as the effective temperature of the sun. Okay, and this is known as the effective temperature of the sun. Okay, so that is the concept. So that what is mean by the solar radiation, and this temperature is then used to get the spectral distribution of the energy which is received from the sun by the earth outside the atmosphere. So this type of radiation which is known as the solar radiation or sun radiation, and this temperature is used to get the spectral distribution. Okay, and that energy received from the sun by the earth outside surface, the energy which is received from the sun from the outside surface of the earth, so that radiation which is considered as the sun radiation, and we have to this that this temperature is then used This temperature is then used. This temperature is then used to get spectral distribution of the energy, to get spectral distribution of the energy which is coming out or which is considered as received from the sun, which is received from the sun, and by earth outside its atmosphere, by earth outside its atmosphere. Outside its atmosphere. Okay, so this is one of the application or one of the example which is considered as so this solar energy which is work to use the black body concept, which is the approximate which is radiation passes through the actual body. And the first example which is considered as what is mean by the sun radiation. So that is concept which is depends upon the approximation which is given or assumption is given if we consider the sun is a black body, and if we consider that sun is a black body that having a huge amount of temperature, that range which is considered as 5762 degree Kelvin, something like that. So that huge amount of temperature, so that energy which is passes from the sun or energy received from the sun to the outside of the earth's surface. So this type of radiation which is considered as the sun radiation. And next type of radiation which is considered as the sky radiation. Okay, so next type which is considered as the sky radiation. Okay, so this is the first type, that is the sun radiation. Okay, and second type which is considered as the sky radiation. If we consider, okay, first of all, in sun radiation, that sun is our black body, and in sky radiation the sky is considered to be a black body and at some equivalent sky temperature. So that first assumption is there, the sky is considered to be the sky is considered to be a black body, and this radiation, this temperature which is considered as the at some equivalent sky temperature. Okay, the sky is considered to be black body at some sky temperature range and at some equivalent sky temperature range, some equivalent sky temperature range. Sky temperature. So that range we have to, so that is this temperature is then used to calculate the exchange of heat between sky and the solar collector surface with emittance epsilon at the temperature T, which is given as. So that this temperature is then used. This temperature is then used. This temperature is then used to calculate the exchange of heat to calculate the exchange of heat between the sky and the solar collector surface. between the sky and solar collector surface okay. So this type of radiation which is considered as the sky radiation, and if we denote, so that this is the assumption or this concept which is related to the emittance at the temperature T, so that this the transfer of heat or the exchange of heat which is considered as the exchange of heat between the sky and the solar collector, which is considered as with emittance epsilon and which is considered as the at temperature range T and at temperature T and at temperature T. And if we give that relation which is considered as that heat relation, so that relation which is given as that capital Q is equal to epsilon into A sigma epsilon into A sigma into T sky power 4 T sky temperature, so that is temperature of the sky as which is considered as the black body minus that temperature, that common temperature, so that is the T power 4, that here Q which is nothing but the heat or exchange of heat which is depends upon that emittance A, area which is considered as the A, emittance epsilon, and conductivity which is considered as the sigma, and this which is depends upon the T sky power 4 minus T power 4 okay. So this relation, so this which has given the very simple expression for the what is the sky temperature range okay. So this is the idea which is considered as the transmittivity of the solar radiation, and that is which is considered as this type of solar radiation which is from two types or two example for solar energy. For solar energy work which is considered as use of black body, that first type of radiation which is considered as the sun radiation, and second type of radiation which is considered as the sky radiation. Now next lecture we want to see the last point of this chapter and last point of the heat transfer which is considered as the convection, heat transfer by the convection, and that is the process of the heat transfer of heat from one region to another by the motion of the fluid, So this is the part of the understanding the concept of the what is meant by the convection. So that point we will be seeing in the next lecture. Thanking of you.